Hi everyone. I just wanted to make a little video to go along with Mrs. Stevenson's video. One to show you how to solve these again with calculators, which I discussed in my previous video. And then when we get to class example 3B, I do that slightly differently than she does. So I will show you that. So if we were just to look at class example 3A, we need to get 27 and 81 the same base. So you would look at, for example, base 2, and you can't get to the number 27. Then you would go to base 3, right? And you'd say, okay, can I convert base 3 to the number 27 and 81? So on my calculator, I would go to y is equal to, put in whatever base you're checking, and remember it's 3 to the power of x. Then if I go to the table, here's 27. 3 to the power of 3 is 27, and 3 to the power of 4 is 81, right? So that's just an alternate way that you could do this. So 27, rewriting this in base 3 is 3 to the power of 3. And then outside of the bracket, I have x minus 2. Because it's a binomial, I'm going to put that in the bracket, and I need to distribute it. So this would be 3 to the power of 3x minus 6 is equal to 1 over. We're going to convert 81 to base 3. And remember from our calculator, 81 is 3 to the power of 4, would give you 81. So I'll say, okay, 3 to the power of 4. And then outside of the bracket, I have the binomial plus 3. And because it's a binomial, I'm going to put that in the bracket, distribute that guy in. So from here, I have 3 to the 3x minus 6 is equal to 1 over 3 to 4x plus 12. Now, when we bring this base up to the numerator, we need to put a negative in front of the exponent, but because this is a binomial, I need to put a negative in front of a bracket, okay? So what this essentially becomes, let me just add some space for us. Okay, so what I'm getting is 3 to the 3x minus 6 is equal to, again, when you bring this up, the exponent becomes negative, and that negative applies to the entire exponent, which is 4x plus 12. That exponent, that negative one, will get distributed in. And remember, at this step here, I essentially have the same bases, so I could drop my bases, and I get 3x minus 6 is equal to negative 4x minus 12. And at this stage here, we're just going to isolate and solve for x, right? So let's add 4x to both sides. And that would give me 7. And let's get rid of that negative 6 by adding 6 to both sides. And if I do that, negative 12 plus 6, divide both sides by 7, and I get my final answer of x is equal to negative 6 over 7. Okay, let's quickly look at this one because I would have actually approached it differently than Miss Stevenson did. Here's how I would have approached this. A question like this, if I gave you, for Math 10C, let's say I gave you 3 over 4, and it doesn't matter what the exponent is, but let's say it's a negative 2x. In 10C, what we would have done is I would have said the first thing I want you to do is change that negative 2x to a positive 2x. And in order to do that, if you have a fraction, you take the reciprocal of the fraction. So that would be 4 over 3 to the power of 2x. So right away, if I was starting this question and I saw a fraction here, and it was raised to a negative exponent, I would say, okay, what I want to do is I want to change that negative x over 4 to just x over 4. You just get rid of the negative exponent. But in order to do that, you take the reciprocal of the fraction. So this would be 216 over 125 is equal to 6 over 5, and that is the power of 3x minus 3. This is always already in lowest terms, and this gives you a really good hint about what we are going to reduce 216 to. And so 216, we're going to reduce it to a base of 6, and 125, we're going to reduce it to a base of 5. So I mean, you do your prime factorization, or you could just go to your calculator. Let's go to base 6. So 6 to the power of x, and let's look at our table. There's 216. So 6 to the power of 3 is 216. We need to check 5 to the power of 3. Is it going to give us 125, right? Because again, if this isn't 6 over 5, I want this to be reduced to 6 over 5. So 6 over 5. So we already verified that 6 to the power of 3 is 216. So we'll put a 3 here. And let's check with the 5. Is 5 to the power of 3 125? Right? So there's two different ways I could check that. But if I put a 5 as my base, second function table, 5 to the power of 3 is 125. Okay, and that was all to the power of x over 4. And that is equal to 6 over 5 to 3x minus 3. My bases are 6 over 5. I'm just going to clean this up. I'm going to multiply that 3 times the 1x. So on the left-hand side, I would have 6 over 5 to the power of 3x over 4 is equal to, on the right-hand side, 6 over 5 to the power of 3x minus 3. Bases are the same. Drop your base and you equate your exponents. So 3x over 4 is equal to 3x minus 3. X is being divided by 4. The opposite of dividing by 4 is multiplying both sides by 4. 3x is equal to 4, 8, 12x minus 12. Let's subtract 12 from both sides. Or maybe what I'll do is this. I'll add this 12 to bring that over there. And I will subtract 3x. So I'll have 12 on the left-hand side is equal to 9x. From here, isolate your x by dividing by 9. And x is equal to 12 over 9, which reduces to 4 over 3.